So we are back to oceanography now. We are going to do some physical oceanography, so talking about the flow of materials, specifically in coastal environments like estuaries. Take this off. Today we're going to review estuaries and density concepts. We're going to understand classification of estuaries by circulation patterns. We're going to explore data involving salinity and tides in a river in the Chesapeake Bay, and understand the impacts of Mississippi River flooding in 2019. The learning goals for today are to understand that estuaries can be classified by varying levels of flow and mixing, that tides move through estuaries in dynamic and interesting ways, that the rivers feeding into the bay add their own dynamics to the flow in estuaries, and that estuarine hydrodynamics can lead to consequences for real people, including record flooding on the Mississippi in 2019, which also led to consequences in neighboring states. So that was pretty far-reaching. We'll talk about that. In Chapter 4, you're going to read about how the Spanish conquerors sailed right into the delta, or the mouth, of the Mississippi River, but didn't even realize they had discovered a river. Part of the reason they didn't realize this is because there's a large, muddy freshwater plume that extends far beyond the mouth of the river. So you can see here, this is the Mississippi River Delta, and there is a lot of material being spewed from all of these little branches or distributaries of the river. And so it can make it really hard to figure out where the main channel of the river is, because you can see that you're in muddy water, but you may or may not be very close to accessing the main channel of the river. And this conceals the river's exact location. So it wasn't entirely their fault. And today we're going to understand why that is. We're going to learn about estuarine hydrodynamics, which is the motion of fluids in estuaries. And just to review, an estuary occurs in coastal environments where fresh and saltwater mix. So we went over this in the first week of class when we went over coastal features. In order to understand estuarine hydrodynamics, we need to review density. This is a concept that we spent quite a bit of time on in Intro to Oceanography. For those of you that did not take that class, we'll review it now because it's important. Density is a really important concept for understanding the structure of the ocean. And what density means is just the mass of a substance per unit volume of that substance. So it's just mass over volume, that's it. It's an expression of the relative heaviness of a substance. And in the ocean, you get this important property known as density stratification. The ocean is stratified based on density, and density is based in large part on temperature and salinity. That means if there are large differences in temperature or salinity between two water masses that are trying to mix, those differences actually prevent them from mixing. So they cause like visible layers in many cases within the water column. So just to go over this image over here, we have a couple of different types of density stratification that occur. One is a thermocline, which is where stratification occurs because of differences in temperature. Warm water will sit on top of cold water. When that water cools, it will sink. When water heats up, it will rise. And then we have a stratification that can occur because of salinity, and we call that a halocline. Fresh water sits on top of salt water. So when you have fresh water moving and trying to mix with salt water, that fresh water will actually move over top of the salt water. Water moves in an estuary based on a specific pattern, based on the flow of fresh water into that estuary, the tides, and the winds. So all of these things can change patterns of flow and can change how these different fluids are mixing. we get more dense seawater traveling landward along the bottom. And that's because seawater is very high in salinity, has a lot of materials in it that makes it heavier per unit volume, and it's going to travel below lighter freshwater. The salt itself causes that increase in density. And then we have less dense freshwater traveling seaward along the surface. And so if you've got a river meeting the sea, that river water is traveling along the surface, the seawater is traveling across the bottom. There can be varying levels of mixing based on density differences and the amount of movement that's occurring. So if you have very, very strong river flow, that river, when it meets the sea, can cause a lot of mixing, and you might not get that freshwater lens. If you have a lot of tidal movement bringing water in and out, you're going to get a lot more mixing, and you might not get such a big difference between the different layers of water. So what you typically get is not necessarily just one lens of water that never mixes with the ocean water. What you get is generally these like laminations that happen. So the fresh river water makes it a little bit further out, and you get some fresher water on top than at the bottom if you're looking at a transect from top to bottom. At each of these lines, this is typically how these things are represented. Each of these lines might represent different salinities. And so over here we have really fresh water. This is slightly less fresh, all the way out to salty water. So you can see if you were to take a transect from top to bottom, you'd be going through fresher water at first and then saltier water at the bottom. So we can classify estuaries based on their mixing patterns, and here are a few basic definitions. A salt wedge estuary has saltwater that intrudes in a wedge along the bottom. And so that's going to be, for example, this one up here. So the salt water is intruding, and you can see that wedge shape, that triangular shape along the bottom. The freshwater flow in this case is sufficiently strong that it prevents the salt water from reaching the surface throughout the estuary. So you're going to get a lot of fresh water in the surface in an estuary like this. A highly stratified estuary usually only happens when there's some barrier to saltwater intrusion. So in this case, that barrier prevents that salt water from doing a lot of mixing, and you get a very defined, pretty much flat freshwater lens on top, moving out to sea. A partially mixed estuary is somewhere in between a salt wedge and a well mix, which we're going to talk about next. So in this case, you can see that the salt water does reach the surface in this estuary. Pretty salty water does. But there's still that triangular pattern, those laminations of different water salinity types. So that's what that would look like. And then a well-mixed estuary means there's really no difference in the salinity from top to bottom. You can see if you were to take a transect from top to bottom, you'd be looking at the same color, which denotes salinity here. This means the salinity at the surface and at the bottom is similar at all points in the estuary. So you can see now how a partially mixed estuary is somewhere in between the well-mixed version and the salt wedge, with highly stratified being kind of a special case. So to give you some examples of estuaries with these different classifications, we have salt wedge estuaries, which are typical of the Mississippi River Delta, the Columbia River Delta, and the Rhone River Delta. So that would be like the Rhine River that runs through. through Europe. Those would be some classic examples. Well-mixed estuaries include Albemarle-Pamlico Sound, Delaware Bay, and the Godavari River estuary that feeds into the Bay of Bengal. Albemarle-Pamlico Sound's right here. That one's in the Carolinas. And then partially mixed estuaries, somewhere in between, would be Puget Sound, which is the estuary that's near Seattle, Chesapeake Bay, which we've talked about, was formed from a meteor strike, and the Changjiang estuary that feeds into the East China Sea. So what do you think would be an example of a highly stratified estuary? So that's a weird case. What do you think would cause that kind of interruption in saltwater flow? Fjords, yeah, absolutely. So fjords often have a highly stratified classification because of the glacial moraine or sill at the seaward edge of the fjord, which blocks saltwater flow and prevents a lot of mixing from happening.